Vistam 151, go around.
Go around, Vistam 151.
Vistam 151, heavy, thanks. The last departure lost the wheel on departure, so we're going to have to shut the runway down. So fly runway heading and maintain 3000.
Roger, Vistam 151.
Omicron 7 heavy, we're going to have to close.
Welcome to Brasher Warning, the podcast that dives deep into aviation incidents with sharp analysis, insightful discussions, and just a touch of edge. If you're passionate about aviation and love a good post-incident breakdown, you're in the right place. Before we take off, be sure to subscribe, leave a review, and share with your crew. Let's get into it.
Today, we're going to be taking a deep dive into a pretty somber chapter in aviation history. It's the crash of Pinnacle Airlines Flight 3701. Back on October 14, 2004, this repositioning flight, a Bombardier CRJ-200, crashed near Jefferson City, Missouri, tragically taking the lives of the two pilots that were on board. Now, while there were no passengers on this particular flight, it really does serve as a stark reminder, I think, about the fragility of life and just how important safety is in aviation. So we're going to be examining the National Transportation Safety Board's investigation to understand not just what happened, but more importantly, why. Our goal here is to really uncover the chain of events, the decisions that were made that led to this tragedy, from human factors to technical issues, so that we can maybe glean some valuable lessons for the future.
Yeah, I think it's crucial to approach this deep dive with respect for the lives that were lost and a commitment to learning from this tragedy. As we'll see, the investigation revealed there was a series of missteps and just unfortunate circumstances that ultimately culminated in this catastrophic event.
We're talking about the pilots, air traffic control, the specific types of engines that were involved, those GE CF34-1 and CF34-3 engines, and how all of these played a role in this tragic story.
Yeah, and a story it is, one that unfortunately demonstrates how even seemingly small deviations from protocol, combined with unexpected technical challenges, can lead to devastating consequences.
Okay, so let's unpack this a little bit. The flight originated in Little Rock, Arkansas, headed for Minneapolis. Early in the ascent, the pilots, a captain and a first officer, began making some unusual moves. The NTSB report details 3 aggressive pitch-up maneuvers that exceeded standard procedures. In fact, they even activated the stick shaker, which is a stall warning, almost immediately after takeoff. It's pretty jarring to think that happened so early in the flight.
Yeah, it is concerning because that stick shaker, that's a loud and clear signal to the pilots that the aircraft is approaching a stall where the wings lose lift. Activating it right after takeoff suggests a risky approach to the ascent, as something you wouldn't expect from experienced pilots.
And what makes it even more puzzling is that the cockpit voice recorder, the CVR, actually captured the pilots' reactions. It seems they were excited about reaching the maximum operating altitude of 41,000 feet.
Yeah, and that's really where the deviation from professional conduct becomes apparent. The NTSB report explicitly states that this climb to 41,000 feet wasn't operationally necessary. It was driven by personal reasons. There's even a quote from the captain to air traffic control where he says, "We don't have any passengers on board, so we decided to have a little fun and come on up here." And, it highlights a lapse in judgment, treating this complex, sophisticated aircraft as something to be pushed to its limits for personal gratification.
Yeah, It's unsettling to hear that, especially knowing the tragic outcome. It underscores how crucial it is to adhere to procedures and maintain professionalism, regardless of the circumstances.
Absolutely. The NTSB concluded that pushing the aircraft to its limits in this way, especially during the climb, placed it in a dangerously low energy state, meaning it was flying too slow for its altitude with very little room for error, and that decision really set the stage for what happened next.
So it wasn't just those aggressive maneuvers that put the aircraft in this precarious low energy state. The report mentions their use of the autopilot played a role too. Can you explain that?
Of course. They were using the autopilot's vertical speed mode, which maintained a constant climb rate of 500 feet per minute. However, this didn't account for the decreasing airspeed as the aircraft climbed higher. Imagine driving a car uphill and only focusing on keeping the speedometer needle steady. You might maintain a constant speed, but you're not accounting for the increasing strain on the engine and the potential for stalling out if you don't adjust your approach.
That's a great analogy. So we have a combination here of aggressive maneuvering and this autopilot configuration, both contributing to this critically low energy state at 41,000 feet. What happened next?
Unfortunately, what followed was the event we were all dreading to hear about, the stall,
Right.
engine flame out.
Okay, let's delve into that a little bit. What exactly led to the stall?
Well, remember that stick shaker warning we talked about earlier?
Yeah.
Well, it activated again, signaling that the aircraft was approaching a stall. This time, however, the pilot's reactions were instinctive, but unfortunately incorrect. Instead of pushing the nose down to gain speed and recover from the stall, which is the standard procedure, they instinctively pulled back on the control column.
So they tried to lift the aircraft even further when it was already losing lift. It seems counterintuitive.
It is, but under extreme stress, pilots can sometimes revert to instinctive responses, even if those instincts are wrong in that particular situation. Their training should have taken over, but in this instance, it tragically didn't. And this exacerbated the stall, creating a very dangerous situation. The NTSB report describes what happened next as a dramatic upset event. A 29-degree nose-up stall, followed by an 82-degree left-wing down roll, and then a 32-degree nose-down pitch. Imagine being on a roller coaster that suddenly malfunctions, throwing you around violently. That's pretty much what happened to this plane. This wild maneuvering disrupted the airflow to both engines, leading to a dual-engine flameout at 34,000 feet.
A terrifying situation for any pilot. So now they're plummeting toward the earth, thousands of feet in the air, with no engine power. What do they do?
They managed to regain control of the aircraft after that initial upset, which is commendable, but their new challenge became restarting those engines. A daunting task made even more difficult by the situation they had created.
And that's where those GE CF34 engines come into play, right? Specifically, the issue of core lock. Can you break that down for us?
Absolutely. When those CF34 engines flamed out at high altitude and high power, some components inside got extremely hot. If the engine cores aren't rotating fast enough during a restart attempt, those hot components can essentially seize up, get stuck. Think of it like a car engine overheating and parts fusing together. That's essentially what core lock is. A mechanical failure caused by the extreme heat and lack of rotation.
So how do you restart a jet engine in midair anyway? The report mentioned windmill restart and APU-assisted restart.
A windmill restart uses the airflow over the wings, the wind created by the plane's forward motion, to spin the engine's fan blades fast enough to reinitiate combustion. It's like a pinwheel catching the breeze, but much more complex. The key is maintaining a high enough airspeed to get those blades turning.
And there's a specific airspeed required for this to work.
Yes, the minimum airspeed to keep those engine cores rotating for a successful windmill restart was 240 knots. But the pilots only achieved 236 knots.
Just 4 knots short. It seems so close.
It does, but remember, they were dealing with an aircraft already in a low-energy state and likely grappling with the shock and stress of the engine flameout. Those missing 4 knots, combined with the high-altitude flameout, led to core lock in both engines.
So the windmill restart failed because of core lock.
Right.
What about the APU-assisted restart?
The APU, or Auxiliary Power Unit, is a small jet engine in the tail of the aircraft. It provides power when the main engines aren't running, things like electrical power, and importantly in this case, compressed air for starting the main engines. Think of it like using a little booster battery to jumpstart a car.
But even that didn't work.
Unfortunately not. The APU has a maximum operating altitude of 15,000 feet. So they had to descend significantly before even trying this restart, and by then the damage was already done. Because those core components were seized due to core lock, even the APU's power couldn't get those engines turning again. It's like trying to crank a car engine that's already seized up. No matter how much power you apply, it's not going to budge.
So at this point, they're gliding, descending rapidly, and they've exhausted all their restart options. This is where communication with air traffic control and the pilot's decision-making in those final moments becomes critical, right?
Absolutely. The NTSB found that the pilot's communication with air traffic control was delayed and didn't accurately reflect the severity of their situation. Initially, they reported a single engine failure, not a double, which likely influenced the guidance from air traffic controllers.
It sounds like this miscommunication had significant consequences.
It did. They lost precious time and potentially missed opportunities for a safer outcome. The NTSB identified 5 other airports that might have been within reach had they acted more quickly and decisively after the initial engine flameout. But their delayed communication and focus on engine restart, instead of considering other options, potentially cost them crucial time and altitude.
And sadly, it all culminated in that final descent and the crash.
Yes. The NTSB report details those chilling final moments, the enhanced ground proximity warning system blaring, the captain uttering, "We're going to hit houses," and then the impact. It's a grim reminder of the human cost of these errors and the importance of swift, decisive action in emergencies.
Yeah, it's heartbreaking to think about those final moments. As we've been discussing, this tragedy wasn't just a single event gone wrong, but a series of decisions and circumstances that ultimately led to this outcome. It's easy to get caught up in the technical details. But at the core of this event is a profound human element, the pilots, their actions, and the immense pressure they must have faced.
You're right. And while we can't change what happened, we can learn from it. That's the power of these NTSB investigations, to dissect these events, identify the contributing factors, and hopefully prevent future tragedies.
So let's talk about those findings and recommendations. Where did the NTSB pinpoint the most crucial missteps?
Well, they highlighted several key areas, starting with the pilot's unprofessional behavior and their deviation from standard operating procedures. That climb to 41,000 feet for fun, as they put it, was a critical turning point.
Yeah, it seems like that decision really set a dangerous precedent for the rest of the flight.
Exactly. The NTSB was very clear that it put the aircraft in a precarious state, reducing their margin for error and ultimately setting the stage for the stall and engine flameout.
The NTSB also identified gaps in their training, right?
Yes, specifically regarding high-altitude stall recovery and double-engine failure procedures. They simply weren't adequately prepared to handle the complex situation that unfolded.
And then there's the technical issue of core lock. While it's not something pilots can directly control, it played a significant role in the crash.
Absolutely. The NTSB made recommendations for manufacturers, urging more rigorous testing to determine the precise airspeeds needed to prevent core lock in those specific conditions. Essentially refining that 240-knot figure for the windmill restart to ensure it was truly adequate.
So making sure pilots had the most accurate information to work with in those critical moments.
Right. They also pushed for updated flight manuals and checklists, emphasizing the importance of maintaining that critical airspeed and warning pilots about the potential consequences of failing to do so.
Essentially raising awareness about core lock and giving pilots the knowledge they needed to prevent it.
Exactly. And the impact of this investigation extended beyond just technical recommendations. The NTSB called for airlines to provide more specific guidance on professional conduct, even on repositioning flights. It underscored that safety protocols are non-negotiable, regardless of whether there are passengers on board.
Yeah, it's a sobering reminder that professionalism and adherence to procedures are paramount in every situation.
And this accident led to tangible changes across the industry. Pilot training programs were updated, checklists revised, and awareness of core lock increased. While this tragedy brought immense sorrow, it also prompted concrete actions to enhance aviation safety.
This deep dive has been a heavy one, but it's so important to have these conversations. What are some key takeaways you'd like to leave with our listeners today?
I think it boils down to this. Safety is an ongoing process. It requires constant vigilance, a commitment to learning from past mistakes, and a recognition that even the most experienced professionals can make errors in judgment.
Well said. This accident serves as a stark reminder of the importance of respecting boundaries, following protocols, and maintaining professionalism. Even when we think we're in a controlled environment, it's a lesson that extends far beyond aviation. Applicable to any field where safety is critical.
I couldn't agree more. We owe it to those we've lost to learn from these tragedies and strive to make the world a safer place.
Thank you for joining us on this difficult but crucial deep dive into the crash of Pinnacle Airlines Flight 3701. While the loss of those two pilots is a profound tragedy, we can find some solace in knowing that their story has contributed to greater safety and awareness in the aviation industry. We hope this episode has been informative and thought-provoking. Until next time, stay curious and stay safe.
Thanks for tuning in to Brasher Warning. If you enjoyed this episode, make sure to subscribe so you never miss a flight with us. We'd love to hear your thoughts. Drop a comment or review, and don't forget to share the podcast with your fellow aviation enthusiasts. Until next time, stay sharp, stay safe, and keep soaring.
American 1552, contact center 127.0.
1552, we're going to be Mayday, Mayday, Mayday. We have an engine failure. We're going to return to DFW.
1552, roger. And which runway do you need?
We'll take 18 right.
Roger, American 1552, turn right heading 020, just going to maintain 8,000.